In this lesson, our equations are a little more complex. We continue with the structure that we've set up, but now there's a little extra step that I'm going to bring in, and I'll show you about that in a moment. But first I'd like you to look at these two equations and tell me what you see is different. Hopefully you're recognizing that in this equation, the like terms are on the same side of the equal sign, whereas in this equation, the like terms are on different sides. In lesson 1.2, we looked at equations like this, where you can just combine them and get 3x, but when they're on opposite sides of the equal sign, you can't combine them in that same way. So there's a little extra step, which we'll talk about in a moment. When the variables are on different sides of the equal sign, you must move them by adding or subtracting until all the variables are on one side and all the numbers are on the other. So let's use that in example 1. If you notice the like terms, which in this case is 2x and negative 7x, they're on different sides of the equal sign. If you drop a line down the equal sign, you'll see that they're not on the same side. So you can't just combine them like we did in the past. What you have to do is decide which side you want to bring your numbers to and which side you want to bring your variables to, label it, and then move your terms. So let's move the variables to the right and the numbers to the left. It doesn't matter. You just have to label it so you know and so your reader knows. So then you go through the equation, so N stands for numbers and V stands for variables. So then you go through the equation and you look at each piece and you figure out who's on the wrong side. So 15 is a number, right? It doesn't have a variable, so it's just a number 15. And that belongs on the left because that's where I chose to put the numbers. The negative 2x, or the minus 2x, does not belong on this side because it has a variable, so it belongs over here with all the other variables. So the way that you inverse minus 2x is with plus 2x. So I'm going to plus 2x on both sides, and I'm going to bring down what's left. So I have 15, and then negative 7 plus 2 is negative 5x. And then you continue looking, and you say, okay, is everything over here a number? Because that's where the numbers belong. Yes. Is everything over here a variable? Yes, because that's where the variables belong. So the next inverse, since everything is where it needs to be, is not addition, because this is not subtraction, it's multiplication of a negative. So the next inverse, if it's a multiplication, is to divide by negative 5. So you get x equals negative 3. It says to check. So let's do it, and especially with the more complex equations, you want to make sure that you do. So I'm going to rewrite the equation 15 minus 2, but instead of putting x, I'll put negative 3. Now what's tricky about these equations is you don't know what number you're supposed to get on each side. The only thing you know is that it should be the same number. So you just follow regular order of operations. We're not doing any inversing. We're not doing any distributing, just regular PEMDAS. So first thing is going to come is this multiplication. So I have 15 minus negative 6. And then on the right-hand side, there's only one operation, so I'll get 21, right, positive, because a negative times a negative is a positive. And when I add, right, turn that to plus positive, I get 21 on the left, and that's what I got on the right, and so you know that it worked. So negative 3 is the value of x because I got the same number on both sides. All right, let's check out some more complex equations. Now, when you are moving things, it doesn't matter who's on the left and who's on the right in terms of whether you put numbers on the left or you put numbers on the right. Whichever one you choose to do, just label it and follow the steps. But before you do anything in letter A, we have to distribute. So I get 15x plus 6 equals 15x. So now I drop a line, and I'll bring, let's bring variables to the left, because it's the opposite of what I did before, so I'll show you it doesn't matter who goes where. So this 6 has to go away. So I will subtract 6. And so you get 15x equals 15x minus 6, because it doesn't combine with the 15, because the 15 is a variable term and the 6 is a number. And now the 15x over here has to move to the left because it's on the wrong side. So I will subtract 15x. So I get 0, because anything minus its exact self is 0, right? There's no x's left. It's just the number 0 equals negative 6. Now that's ridiculous. Hopefully you're looking at that and you're saying that's false. That's not true. When you get a false statement like this at the very end, like the variable disappears and you have two numbers and they're not even equal to each other, the answer is no solution. So instead of writing x equals some number, the answer is that there is no value for x. No number that you plug into this equation up here is going to work. Nothing. No matter what you plug in, they're all going to be wrong. Let's check out another one. Same thing over here. First thing we want to do is distribute. So I get negative 8y. Negative 2 times positive 1 is negative 2. And now, if you're looking at this and you're going, it's the same thing on both sides, you're on the right track. Let's just do a couple more steps. But I like your thinking if you notice that. So let's drop a line, and I'll bring numbers to the left, variables to the right, just to change it up because I want to show you it doesn't matter. So this 8y has to go away because it's not a number. So I'll add 8y. And I'll bring down what I have left. Oh, they actually cancel here as well. So I just bring down the negative 2, because if they cancel, don't write anything. And then same thing. You have negative 2 equals negative 2. We're like, duh, that's true, right? That's a true statement. If you have something that looks like this, then the answer is that there's an infinite number of solutions. I'm abbreviating with the number sign. Infinite number of solutions. Sometimes you'll see books write what it says up here, infinitely many solutions. That means the same thing. What that means is that no matter what number you plug in, it's going to work. So you could plug in 2, you're going to get a true statement. You could plug in 10, you're going to get a true statement. You can plug in negative 3.3 repeating, you're going to get a true statement. Anything you plug in is going to work. All right, let's check out this word problem. The circles are identical. What is the area of each circle? So in this one, we've got a radius marked, and in this one, we've got a diameter marked. Well, this is a radius, so if you double it, you'll get the same thing. Since they're identical, it's the same thing. So this is x plus 2, right, because it's another radius on the other side. So the total circle is going to be 2x plus 4, the total radius of the circle, or the total diameter. And then the diameter here is 4x. Since the circles are identical, then 2x plus 4 equals 4x. Okay? Drop a line down the equal sign, and let's bring variables to the right, numbers to the left. I'd like you to pause the video right now, try this on your own, and when you think you have the correct answer, play the video. All right, now if you circled choice A, you just fell into a big trap answer, because the question doesn't say what is x. It says what is the area of the circle. So you have to remember the formula for area, or look it up, that area equals pi r squared. So we need to know the radius. Well, if x is 2, then I can plug it in here, because remember from the beginning, x plus 2 was the radius. So 2 plus 2 gives me 4. So the radius is 4. So I'm going to plug in pi times 4 squared. So that gives me pi times 16. And I don't need to calculate it because it's right here, choice C. All right, last one together. A boat travels X miles per hour upstream on the Mississippi River. On the return trip, the boat travels 2 miles per hour faster. How far does the boat travel upstream? And they've given us this this little formula, that distance equals rate times time. So if you don't remember that from science, here's the formula we're going to use it. Well, rate is your speed and time is obviously how long it took you. So if you look at the picture, they actually tell us how long it took us, but they don't tell us the speed or the rate. But they do tell us that upstream it was X miles per hour. And then downstream it was 2 miles per hour faster. So that's going to be X plus 2 miles per hour. Well, if the distance upstream is X and the distance downstream is X plus 2, then we have all the information to use in this formula and we can plug it in. So let's look at the distance upstream. The distance upstream is going to be the rate, which is X, times 3. So that's going to be 3X. And the distance on the return trip is going to be X plus 2 times 2.5. So I have to distribute that. So that gives me 2.5x plus 5. All right, let's move variables to the left, numbers to the right, and I'd like you to pause the video and solve for x. All right, so you get x equals 10, but hopefully you didn't fall into the trick of circling that as your correct answer, because again, it says how far does the boat travel upstream? So now my upstream information is over here. The distance upstream is 3 times, well, now I know x, which is 10, so that's going to be 30 miles. If you have any questions, write them down and ask me when you come to class.